We've got translations, rotations, dilations in the Falcon Nation. My flow's amazing. Woo! We're back to math, y'all, talking today about dilations. All right, dilations, a new and the last type of transformation we're going to be talking about. All right, so we're going to work on graphing dilations, finding scale factor, which is a new term for us, and writing rules of the objects that are being dilated. All right, so what do you guys think a dilation is? All right, so just think about that for a second. What is a dilation? When have you heard that word, and what have you heard it talking about? Hopefully, you've heard it talking about eyes. You go to the doctor, you go to the eye doctor, get your eyes dilated. So this is a dilation. You can see you got a pupil right here. It's small, and then when it gets dilated, it gets really big. So that's an example of a dilation. Also, right here, you've got a Coke can, 12 ounce, and an 8 ounce, a little bit smaller, but it's like the same shape, just shrunk down. Same thing right here with this nice Ferrari and this model Ferrari that you got here. Okay, it's just a little toy car, but it's supposed to be a model. Same shape and everything, but just a different size than the actual size Ferrari. It'd be nice to have one of those. I'm not going to lie about it. So when we talk about dilations here, okay, let's take some notes. So we've got dilation is a type of transformation that produces an image that is the same shape as the original, but a different size. Okay, it's a different size. Could be smaller or could be bigger. So a dilation is another term we use, similar. Okay, similar to the original figure, not congruent. Congruent means exactly the same, in every way exactly the same. A dilation is just similar because it's the same shape, but it's a different size. It's not exactly the same. So our dilations are centered around the origin unless it's stated otherwise, and the ones we're going to be doing are stated around the origin. Okay. So now scale factor, another new term. Scale factor is the image length. Okay, so remember the image is what you end up with, the shape you end up with after the transformation. Pre-image is the shape before the transformation. So you take the length of the new image and divide it by the length of the pre-image, and that will give you the scale factor. Okay, so this can be a number that is greater than 1, or it could be less than 1. Okay, it's either going to be greater than 1 or less than 1. Okay, so if the scale factor is greater than 1, then the figure is going to become larger. So if the scale factor that you find is a number bigger than 1, 2, 3, 10, whatever, it's going to make the figure larger. But if the scale factor is between 0 and 1, okay, or less than 1, I guess I should say between 0 and 1, then the figure is going to become smaller. Might want an S on there. Smaller isn't a word. Okay. So now the rule, we always have a rule for a transformation. The rule for a dilation is similar to the rule for a translation, right? With the one where it shifts left and right or up and down. It looks similar to it. You start with the X and Y like you do with the translation, right? But instead of adding and subtracting something to X and Y, you're going to multiply it by F, where F is the scale factor that we were talking about a minute ago, okay? So now if the scale factor is 3, what would our rule look like? Okay, so our rule, just like translations, is going to start off with X comma Y and the arrow. And now in parentheses, we're not going to add something to X. We're going to multiply it by F, which is our scale factor. So right here, our scale factor is 3. So we're going to multiply the X's and Y by 3. So 3X and 3Y. So this is what our rule would look like if the scale factor is 3. All right. Let's scroll on down. Extend the page a little bit. Okay, so if we have a triangle ABC with vertices 0, 2, 4, 4, and negative 1, 4, what are the vertices of its image with a scale factor of 4? Okay, so this is the pre-image, and we're going to dilate this pre-image with a scale factor of 4. So essentially what you've got to do is take your X, Y's and multiply them by the scale factor. Now you can probably just do it in your head, but you know, it's always a good practice to write it down. I'm just going to do it in my head for you guys because I know y'all are really smart. So A prime is going to be x times 4, so 0 times 4, which is still 0, and 2 times 4, which is 8. So you're just multiplying both coordinates by the scale factor. B prime is going to be 4 times 4, which is 16, and then another 4 times 4, which is another 16. All right. C prime is, of course, negative 1 times 4, so that's negative 4, and 4 times 4, which is again 16. So these would be the vertices of the coordinates of the new triangle, with a scale factor of 4 being applied to this original triangle. Cool. All right, let's keep on cruising. All right, so quadrilateral 3 right here has these vertices. I want to pause it real quick and let you guys go ahead and graph these 4 points on the coordinate plane in your notes. All right. So this should be the shape that you graphed, P prime, Q prime, S prime. Actually, I don't know why I put the primes on it. It shouldn't be the primes. This isn't the image. This is the pre-image still. So I'm going to take those off real quick. Yeah, it shouldn't be primes quite yet. Getting a little ahead of myself. That was awful, but you guys understand. PQRS. All right, looks like a T now, doesn't it? So PQRS is our pre-image. So they want to know what's the coordinates of the image if it's dilated by a scale factor of 1/2. Okay, so scale factors don't have to be whole numbers; they can be fractions. So we're going to multiply all of the x and y coordinates by half. All right. Now, some of you might realize that multiplying by 1/2 is the same thing as dividing by 2. Okay, so when we multiply all these by 1/2, it's basically just dividing by 2. So when I do negative 2 divided by 2, that gives me negative 1. And 4 divided by 2 is 2. Q prime is going to be 4 divided by 2, which is 2, and 4 divided by 2, which is 2. R prime is going to be 4 divided by 2, which is 2. Negative 2 divided by 2, which is negative 1. And then S is going to be negative 2, because half of 4 is 2. All right, so those are going to be the coordinates for my new point, or my new shape right here, my new quadrilateral. All right, so let's go ahead and graph those and take a look at them. Negative 1, 2 is P prime, so negative 1, 2. All right, and then Q prime is 2, 2. 2, 2, huh? Like a ballerina wears. All right, and R prime is 2, negative 1. And S prime is negative 2, negative 2. All right, and we'll connect those as best we can on this little weird tablet. Still trying to use this thing. Whoa, got a little curve in there. No big deal. All right, you guys get the gist of the shape. Okay, so now if you look at this, you can tell what we talk about when we talk about dilations, how they're the same shape, right, but they're a different size. These basically two shapes look like kites, right? They look kind of like a kite that you would fly. And notice the angle measures. All right here, this is like a 90-degree angle. Right here, it's also making a 90-degree angle. Down here, you've got something a little bit bigger than 90. And right here, it's a little bit bigger than 90. So all the angle measures, all right, seem to be the same. So let's look down here at B part. Demonstrate these quadrilaterals are similar by comparing the ratios of the lengths. Okay, so the lengths of these sides. So let's just count these real quick. What's the length from P to Q? 1, 2, 3, 4, 5, 6. All right, so that's 6. All right, now what is the same side, all right, from P prime to Q prime? All right, so this was P prime. Now you can put your primes on there, Coach Shipley. All right, so there's P prime, Q prime. So the length of this side now is 1, 2, 3. All right, 1, 2, 3. So P prime, Q prime is 3. So now when we compare the lengths of the ratios of the lengths, okay, they should all be the same. So the ratio of these two sides should be the same as the ratio of the other sides. So this one is 1, 2, 3, and this one is 1, 2, 3, 4, 5, 6. So you can already tell they're the same, so they should be the same ratio. But let's just look and see. So remember, we talked about scale factor, right? On the last slide is your the length of your image, okay, the new image divided by the length of the pre-image. So our new image is 3 divided by our pre-image, which is 6. Okay, and we know 3 over 6 is going to reduce to 1/2. Alright, so this is our scale factor. Okay, so I'm going to just write that here for you. This is my scale factor. So if we did our shape right, the scale factor should be the same for all the side lengths. If we found the lengths of these two using distance formula and the lengths of those two using distance formula, they should still be 1/2. And as you can see on this one, it's also going to be 3 over 6, which is going to be 1/2. So those two are the same, which just shows that they're similar, right? Alright, so let's look at C part. What do you notice about the angle measurements of the two figures? I kind of talked about that a minute ago. You can tell the angle measures are the same. Alright, so the thing to notice is whenever you do dilations and you get similar figures, okay, whenever you get similar figures, the angle measures are the same measure. So we get the same angle measures. Alright, does that make sense? So, don't know why I'm asking you really. You can't answer. It's a video, right? But you can always stop me and be like, Coach Shipley, that makes sense. And I'll know what you're talking about. Alright, so let's keep on rolling. Keep rolling, rolling, rolling. What? Alright, so example 4 here. The scale factor is 5/2. How would you write the general rule? Alright, so I'm going to go ahead and pause it here and see if you guys can write the rule and also tell me if it's an enlargement or a reduction. You guys had fun with that problem. I know it was an invigorating math problem to say the least. But if you can see right here, this is the answer. X, Y should translate to 5/2 X, comma 5/2 Y. And this is an enlargement because 5/2, our scale factor, is greater than 1. If your scale factor is greater than 1, it's an enlargement. If it was between 0 and 1, then it would be a reduction. All right, let's keep on rolling. All right, so we got quadrilateral A prime, B prime, C prime, D prime is a dilation of quadrilateral ABCD. Find the scale factor and classify the dilation as an enlargement or a reduction. Okay, so we can see real easy if our pre-image is ABCD and this is our image, then obviously this is a reduction. Okay, it got smaller, so it's easily seen right here that this is a reduction. So now, but we got to just find the scale factor. So remember, scale factor is the length of an enlarged the new shape divided by the length of the old shape, right? So any length between 2 points will give us the scale factor that we can figure out using that ratio. So let's look and figure out the length of one of the shapes of the pre-image. Okay, so right here we've got AB and we've got AD and CD and CB. Okay, and we can count all those to find the lengths, but we have to use distance formula, okay, on these because we can't just count, I guess, from one to the next, because it's not a straight line going straight down to it. So one thing that we could do though is count from B to D. Okay, so we could count through here and see how long that is. So our new image is 1, 2, 3, 4. Okay, just keep us from having to do distance formula. And we need to divide that by the same line, right? The same line going straight down through the middle of our original image, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it'd be 4 over 12, which is going to reduce to 1 over 3. So that is our scale factor. Scale factor is always the length of the image, right, divided by the length of the pre-image. And as you can see, scale factor is 1/3, which is less than 1, which means it's a reduction. Whenever it's bigger than 1, again, it's an enlargement. So that one is definitely a reduction. Let's keep on cruising. Last example here. All right, so I'm going to pause it and see if you guys can at least do the first part. Okay, so just do the dilation using a scale factor of 2. Okay, so I try to make this with a dilation of scale factor of 2. So we can see right here our new coordinates x prime, y prime, z prime. All right, so what you had to do was take all of the points and multiply their coordinates by the scale factor which was 2. Alright, so you had to multiply all of the points by 2. -1 is now -2, -2. -1, 2 is now -2, 4 when you multiply them both by 2. And then the point 1, 1 is 2, 2 because you multiply them both by 2. And when you graph these points, here's what you get. You get this nice, pretty triangle if I don't mess it up. That wasn't half bad. Alright, so there's our new triangle, x prime, y prime, z prime. Alright, now let's look at this part right here. So one thing that you're going to have to do on assessments is do 2 transformations on one problem. So we just did one, right? And now, and this was actually the bonus questions on your quiz. So the second part says, what were the coordinates of point y double prime, which just means now do a transformation on the primes to get y double prime after a flexion of polygon x prime, y prime, z prime over the x-axis. Okay, but they don't want the whole thing. They just want one coordinate, y double prime. So if I did a reflection now, actually let me pause it, see if you guys can figure it out, and I'll tell you. Alright, so right here we drew our reflection line because it says reflected over the x-axis. So here's our x-axis. So all we need to do is count how many spaces y prime is from the x-axis and then reflect it that many spaces on the other side of the x-axis. So y prime is 1, 2, 3, 4 spaces above the x-axis. We're going to reflect it 1, 2, 3, 4 spaces below the x-axis to get y double prime. So right here's where the y double prime would be. So we can say that y double prime is going to have the coordinates -2, -4. Alright, so this is one thing we just got to get good at, is doing a double transformation on one item. Okay, and it's really simple. It's just 2 problems in one. Do one transformation, then on the new image, do a second transformation. Alright, well, I appreciate your guys' time watching the video. Let's go ahead and practice, and love you guys.